Hi guys, welcome to the next section, Server Provisioning, using Ansible. In this section, we will look at server provision software. We will then see Ansible configuration. After that, we will go through Ansible variables and templates. Now, we move on to the first video of this section that deals with server provision software. In this video, we're going to take a look at Chef, Puppet, and Ansible. Let's start with Chef. Chef is a very interesting software that follows the Bastion host principle to run configurations on our servers. A Bastion host is a server placed in our private network that is able to reach our servers directly or via proxy in order to execute the actions needed to set them up with the desired state. For example, Ansible needs to improve via third-party software, such as Ansible Tower from Red Hat. Chef uses recipes to configure parts of the server. A recipe is basically a set of declarative instructions that define what needs to happen in order to get the server to the desired status. For example, let us take a look at this code. This code will upgrade our system and then install the Apache 2 web server. This recipe, once finished, gets uploaded into the Chef server from a workstation, and here is the key present. In Chef, there are three actors: server, workstation, and nodes. The server is where the recipes and configuration live. There are three modalities of the Chef server. The first modality is Enterprise. This can be installed inside your infrastructure, and it is licensed, so you need to pay depending on the numbers of nodes that it is managing. The next modality is Open Source. This can also be installed in your infrastructure, but it does not have any support. It is free and has to be configured and maintained by your company. It is also a cut-down version of the Enterprise Chef. The Chef server is hosted on third-party hardware, and you don't need to worry about maintaining and upgrading it. It might not be an option depending on the setup of your company. The nodes are the target hosts. Every node is registered in the Chef server and has a run list that is a list of recipes that are going to be run on a host when the Chef client command is executed. The workstation is the computer used to configure and upload the Chef server. This computer uses a software called Knife that can do everything on the Chef server. The tasks done are configuring roles, looking for VMs depending on the roles and other parameters, configuring run lists, and managing secrets. Knife uses cryptographic keys to communicate with the Chef server, so all the communication happens in a trusted way. Now, if we want to picture everything, it looks like that is shown in this diagram. As you can see, even though the setup is quite complex, there are obvious benefits. Our Chef server is behind the firewall in the demilitarized zone of our infrastructure. It is managed via a CLI tool, so all our secrets and configuration are safe inside our infrastructure. Chef has a steep learning curve that once we've gone through the initial learning phase gets very familiar and easy to add new features. It extends the DSL with the power of Ruby and a very well thought out interface. Now let's move on to Puppet. Puppet has been around for a while and is widely used in the DevOps world. Puppet comes in two flavors: open source and enterprise. The open source version comes as is, offering a good set of features that allow you to fully automate the configuration management of your infrastructure. The Enterprise Edition, aside from support, comes with an extended set of features that make the life of the engineers in your company a lot easier. In the same way as Chef, Puppet follows the Bastion host architecture. The server is installed within your infrastructure in the demilitarized zone and the nodes via the Puppet agent. It will execute the specified tasks to reach the desired status. The main difference between Chef and Puppet is the fact that Puppet is declarative, whereas Chef is more imperative. In Puppet, you specify which state you want your servers on, and Puppet takes care of keeping them there. In Chef, you declare a number of steps that will get your server to the desired state. Chef also allows you to declare guards, which are conditions for steps to be executed. Now, let's see Ansible. In my opinion, it is the easiest to learn and extend. It is also easy to understand and offers a fairly comprehensive open source version that works with all the features from Ansible. You can also buy a license of Ansible Tower to run Ansible playbooks in a Bastion host configuration as Chef or Puppet. Ansible is basically a domain-specific language for executing operations on remote hosts that are defined in an inventory. Ansible works by running playbooks in the desired servers via SSH. So, unlike Chef or Puppet, we don't need to install anything in the remote hosts. We should just be able to SSH into them. A playbook is basically a yet another markup language with a set of instructions to get the server into the desired state in the same way as if we were executing a bash script. A playbook looks like this. The file will make you understand how easy and straightforward it is to understand what the playbook is doing. As you can see, in the second line, we're specifying that we want to run this playbook in the hosts called web servers. This can be defined in the other part of Ansible, the inventory. The Ansible inventory is basically a file with the list of hosts in your infrastructure like this. This file is very straightforward, but can get really complicated as well. The names between brackets are groups. The groups contain hosts that can be defined with generators, or they can just be listed. Groups can have configuration specific to them, or even override variables. In this example, we have two groups, web servers and DB servers. Web servers are only two hosts, host 1 and host 2. DB servers use a generator, and we have three hosts, that is 192.168.0.1, 192.168.0.2, and 192.168.0.3. These variables can be scoped on the group and the host. Let's take a look at our inventory. As you can see, we have two variables. The first variable is time zone. This is applied to all the hosts of the group DB servers. The next variable is role. This is applied to the host 1 of the group web servers. This variable can be used in playbooks in order to have a specific configuration for specific hosts. Groups can also be combined into bigger groups. In this inventory, we can find DB servers, web servers, Mongo servers, and data servers. All are ungrouped. Even though we did not specify it, Ansible always has two default groups called all and ungrouped that are self-descriptive. All is all the hosts in the inventory, and ungrouped is all the hosts that are not specified in any group. Ansible does not follow the bastion host architecture as Chef or Puppet, but it follows the client-server architecture. Our host needs to be able to reach the destination hosts in order to work. This can be inconvenient depending on your infrastructure architecture, but it can be worked around using Ansible Tower or Rundeck to execute Ansible playbooks from inside your demilitarized zone. In this video, we've looked at server provision software. In the next video, we will see Ansible configuration.